Good morning. Hope you're all doing well. Um, since we, alhamdulillah, successfully accomplished the producer theory, we will start now with our other pillar of consumer theory. Our coming presentations will go through the coming points or the following points. First, we will define the consumer problem. What do we mean by a consumer problem? And you will find that this is a typical problem for every person who would like to go to the market and buy something. What do we mean by preference relation? What are the axioms? What are the assumptions of the preference relation and the consumer choice? These are all ordinal ranking, but I cannot say that they don't have real numerical values. So we will translate them into real numerical values by using the utility function. So we have to define a utility function. Definitely it will be in a mathematical, using mathematical notations, and to see what are the properties of such a function. Using the preference relation, the utility function, we will use them both together in order to define in detail what is a consumer theory. What is a consumer theory? From which we will start to study the indirect utility function and its properties. Okay, what is the utility function? It's indirect utility function. It's a very easy distinction. Utility function is nothing but the direct utility function, and indirect utility function is like the inverse utility function. So this is specifically like the case of a direct demand function and an inverse demand function. So it's the same. Then we will go to the expenditure function. You will see that all these three functions are more or less the same. The difference is very tiny, and this is why they are all quite related. And in order to show this relation, we will have a separate section trying to figure out the relationship between the indirect utility function and the expenditure function. Finally, we will try to use all these different concepts in order to understand more the properties of the consumer demand in two main cases. The first case is in the case of relative prices of commodities. The second case is in the case of income and substitution effects for any price change. So this is mainly what we are going to take. I'm quite sure that you are familiar with different concepts already from these introductory bullets, and you will see during our presentations of this chapter that you are familiar with the concepts. Maybe we will, or definitely we will get these concepts in a more detail, in more depth, a little bit more depth, but more or less you have the concepts. And definitely you are backed up with your knowledge of the mathematics for economists that you already took last year. Okay, what is the consumer theory? Consumer theory is based on one thing, defining the consumer problem. What is a consumer problem? When I go to the market to buy something, what's my problem? My problem is simply to choose a consumption bundle out of all feasible bundles that is most preferred. So as you can see, there are three main underlying concepts: consumption bundle, feasible bundles, and most preferred. So in order to understand it more, I'm quite sure that seeing it or visualizing these concepts will make it easier to understand. So let's assume, this is just a hypothetical example, that this closed circle is our consumption set X, and this is a closed set, This consumption set has different consumption bundles that a consumer might want to buy, might want to acquire, to get. So let's assume we have 7 different consumption bundles, and we will assume in this consumption set that every bundle is an Rn plus space. What do we mean that it belongs to an Rn plus space? It means that every bundle has n commodities, has n goods. And this plus means that we cannot have any quantity with a negative value. It's either zero or positive, but you cannot consume any quantity with negative. So this is why they are all at the Rn plus space. So these are all different consumption bundles that a consumer might like to consume. However, there is a simple constraint. When you go to the market, can you just say that I want this and that and so on? You have to first look at your pocket and look, do you have enough money, enough financial resources to buy these bundles? If not, so you have to go back home and recalculate your needs with your available resources. So here comes the concept of feasible bundles. So a feasible set is just a subset of the consumption set. Yes, as a consumer, I might like to consume all these consumption bundles, but I only can afford, I only can acquire, I only can buy either X5, X6, X7. They are within my budget. They are within my financial resources, whether from my wealth, my income, or whichever kind of financial resource. So this is my financial set that is just a subset of the whole consumption set X, and that are affordable for me. So the consumer will first plot his consumption set, from which he will determine his feasible set. From this feasible set, he will choose the bundle that is most preferred to him, that will really satisfy his utility at maximum. So let's say it's X6. So eventually, the consumer chooses X6, which is the most preferred bundle to him, that will satisfy his utility at maximum from this feasible set that is only a subset of the consumption set X. So to restate it once again, the consumer's problem is just to choose a consumption bundle out of all feasible bundles that is most preferred. From this definition, we can go or we can come up with four main building blocks of the consumer problem. First is the consumption set, as we saw, our big consumption set. Then the feasible set, which is just a subset of the consumption set. The preference relation. Since I said that I will choose the most preferred bundle from the feasible set, so this means that I have to use the preference relation. I prefer X5 more than X6. I prefer X5 more than X7. So this is a preference relation. Once we get all these three concepts, this means that we reach the behavioral assumption of a consumer. Why do we care about all this? We are saying a consumer theory. We are studying consumer theory. So we are just concerned about studying the behavior of consumer, to understand his behavior. What's it behind his behavior? Why does he choose this over that? Why so? So this is all just to understand his behavior. So once we get the consumption set, feasible set, preference relation concepts, we will be able to put some assumptions over the consumer behavior that will help us later to understand, as we saw in our introductory slide, to understand the consumer demand behavior. The consumption and feasible set. The consumption set X is the set of all possible consumption bundles, and sometimes called consumption plans. As we just saw, the big circle of the consumption set X that has different consumption bundles. Just in our hypothetical example, we just assumed having only 7 consumption bundles, but you might have n consumption bundles, all possible different consumption bundles. We will assume that this set it is an Rn plus space. What do we mean by that? An R, N, and denote that each bundle has n commodities. And why do we have this plus? Because the set of all possible non-negative quantities of n commodities, either to have or at least to have zero quantity consumed of any commodity. But you can never have a negative value for a commodity. So this is why we say Rn plus space. Okay? A consumption bundle X that belongs to the big consumption set X is thus represented by a point X that belongs to what? That belongs to the Rn plus space. Since the consumption set is an Rn plus space, and the consumption bundle X belongs to the capital X or to the consumption set X, so definitely this consumption bundle or the point small x, the consumption bundle X, belongs to the Rn plus space. At last, we have the feasible set B. The feasible set is just a subset of X. Why is it a subset of X? Because it just contains some consumption bundles of the consumption set. Not all of them. It is just some specific consumption bundles of the consumption set are affordable, are attainable, are reachable. So the feasible set B is a subset of X representing the set of consumption bundles achievable, attainable, feasible with the consumer's financial resources like wealth, income, or any other kinds. What are preferences? The consumer's preferences determine which bundles are more preferred. Once I say preference, this means that I can say I prefer X to Y. X and Y are the same for me. It doesn't matter. Definitely, I don't like Y at all. So once I say I prefer, so this means that I can determine which bundle is more preferred than the other. We will characterize the preferences by some axioms, some assumptions, and those are the minimum possible assumptions to have consistent, reasonable consumer preference. So we will just assume that we have two consumption bundles, X1 and X2, subscript 1 and subscript 2, to be any two elements of the consumption set X. So just assume we have a consumption set X, and within which we have different consumption bundles. We will just work with only two consumption bundles, X1 and X2. We say that X1, this sign means at least as good as, at least as preferred as. X1 is at least as good as X2. X1 is at least as preferred as X2. We will see now what do we mean by these words. So, axioms of consumer choice. As we said, we will put some assumptions, some axioms over the consumption choice, over preferences. Consumer choice is just nothing but the preference of the consumer from which he will make his choice. He will determine which commodity to consume. So the first assumption is completeness. For all X1, X2 that belong to the consumption set X, either X1 is at least as good as X2 or X2 is at least as good as X1. It's either or, we just have two bundles. So either X1 is at least as preferred as X2 for me as a consumer, or X2 is at least as preferred as commodity X1, bundle X1 also as a consumer. It's either or. So this assumption implies that consumer can evaluate alternative various bundles, make comparison between them all, and decide if he prefers one good over the other. Definitely we might have a situation in which I don't care, X1 or X2, both are equally preferable for me. I don't care. Some other times I will not say X1 is at least as preferred. No, I will say X1 is preferred than X2. Or make it stronger, X1 is strictly preferred than X2. There are different types of preferences that we will just shortly see. But till then, just all what we need to know from the completeness axiom is that according to this axiom, according to this assumption, a consumer is rational enough, is wise enough, so to evaluate the different, the alternative, the various bundles that he face, that he see, so to make a comparison between them and determine and decide which commodity is preferred over the other. The other axiom is transitivity. And once we say transitivity, this means that we need to have three elements so to be able to grasp the definition, to show the definition of this axiom, or what does this axiom imply. So just assume we have three consumption bundles, x1, x2, x3. If I'll tell you that x1 is at least as good as x2, and x2 is at least as good as x3. So definitely this means that x1 is at least as good as x3. If it happens that a consumer comes and tell you, okay, x1 for me, x1 is at least as good as x2, and x2 is at least as good as x3. But x3 is at least as good. No, it's even strictly preferred than x1. What will you say? You'll just say, are you not? Are you crazy? This is inconsistent. This is irrelevant. This is not logical by any means. So transitivity aims at consistency of preferences. So this implies that preferences are consistent. Although we require only that the consumer be capable of comparing two alternatives at a time, this assumption of transitivity requires that those pairwise comparison be linked together in a consistent way. Pairwise comparison, pair means that two. So x1 with x2, x2 with x3, x1 and x3, those are all pairwise comparisons. The transitivity condition, the transitivity assumption, would like to have or aims at having a pairwise comparison that are linked in a way so they are consistent. So transitivity implies consistency of preferences. So both axioms together, completeness and transitivity axioms together, implies that the consumer can completely evaluate the alternative bundles and rank them all in a way from the best to the worst, so he can choose the one that is most preferred to him. And this ranking is consistent. So the capability of ranking the alternative bundles comes from completeness, and for this ranking to be consistent comes from transitivity axiom. So preferences enable the consumer to construct such a ranking by saying that those preferences can be represented by a preference relation. So let's go to the preference relation. What do we mean by preference relation? A binary relation, when I say binary, means two. So we'll just assume that we have only two bundles. Once I say binary relation, so the relation between only two bundles. So a binary relation, and this notation, as we just said, this sign means at least as good as. A binary relation of at least as good as is called a preference relation if it satisfies the axioms of completeness and transitivity, as we just said. But there are other types of binary relations. So this sign means strictly. So x1 is strictly larger than x2 if and only if x1 is at least as large as x2 and x2 is not at least as preferred as x1. What do we mean by this? Let's first define what do we mean by at least as large as. At least as large as, or at least as, at least as preferred as, at least as good as, means that we have two bundles, and each bundle has n commodities. When I say that x1 is at least as preferred as x2, this means that in bundle x1, all goods might either have the same quantities as x2, and some other commodities might have higher quantities than x2. So this is why we say that it is at least as preferred as, because in some commodities it has higher quantities, while in other commodities it has the same commodity as x2. So this is why we say that it is at least as good as, at least as preferred as. But if I tell you that x1 is at least as preferred as x2, but x2 is definitely not equal to x1, this means that if we put the bundle x1 and the bundle x2, there is no one commodity, one good in bundle x1 and x2 that have the same quantities. So this means that bundle x1, the goods in the bundle x1 has always higher quantities than the other bundle of x2. So in this case, what I will say, I will just say that definitely, I strictly prefer x1 over x2 because I will consume across all commodities higher quantities than when I consume x2. Okay, so here we say that x1 is strictly larger than x2 if and only if x1 is at least as good as x2 and x2 is definitely not equal to x1. Another relation is the indifference relation. I am just indifferent, x1, x2. They are both the same for me. It doesn't matter. I will have the same level of satisfaction, the same utility level. So x1, this tilde is called indifferent. Once I write x1 tilde x2, this means that x1 is indifferent to x2. Is indifferent to x2. If and only if, the IFF is if and only if, I will say that x1 is at least as large as x2 or is at least as good as x2 and x2 is at least as good as x1. What does this mean? This means that both commodities are simply the same. I'm just indifferent. The preference that I will get from both is the same. So x1 is at least as good as x2 and x2 is at least as good as x1 means that as a consumer I will get the same level of satisfaction, the same utility level if I consume x1 or x2. So here I'm plotting the first graph, upward graph with the three indifference curves. When we have a different indifference curves, we call it an indifference set. So different indifference curves indicate an indifference set. The higher the indifference curve, moving to the right, the higher the level of utility and the level of satisfaction. So I1 is a higher indifference curve with a higher utility than I2, and I2 is a higher an indifference curve compared to I3, and it also provides a higher level of satisfaction to the consumer. If we move along every indifference curve, what will we get? We will get the same level of satisfaction. Let's assume that we are just moving along the first indifference curve I1. So at every point, at every consumption bundle, we will get the same level of utility, the same level of satisfaction. So in this case, which preference relation will we use? Weakly preferred or strictly preferred or indifferent? Yes, we will just say that across any indifference curve, all consumption bundles are giving the same level of satisfaction, and the consumer is indifferent across them all. He has the same level of preference. Okay. Looking um, to the second or to the left diagram, you have also an indifference curve, and the green part is called the indifference set. This indifference set, can we call it strictly preferred or weakly preferred? As you can see, the set of bundles that are weakly preferred to X bundles that exist along the indifference curve. Why do we say that they are weakly preferred, at least as good as X? Because as we said, at least as good as mean that every commodity in the consumption bundle will yield either or will give higher quantities or equal quantities. So as we can see, any point in the green area will definitely give higher level of satisfaction, higher quantities than the point along the indifference curve. But if this green area also include the indifference curve, so we have the X. So any point along the indifference curve other than the X will give the same level of satisfaction. So this is why we are saying that the indifference curve plus the green area, all these consumption bundles together, are called weakly preferred bundles to X. Once again, we have an indifference curve, and the area above it, the green area, all consumption bundles in this green area plus the bundles that are along the indifference curve are called weakly preferred bundles to X. Why? Because the bundles that are above the indifference curve, that are located in the green area, give higher level of satisfaction, higher utility, are more preferred than X. But all bundles that are along the indifference curve give the same level of satisfaction, are equally preferred as the bundle X. But to the contrary, looking to the other right-hand side diagram, we see the indifference curve dashed. Means it's dashed, it's like this is an open set. So this means that we do not include the bundle that exists over or along the indifference curve. So we are only considering the gray area that is above the indifference curve. So I'm just trying to compare the consumption bundles that are above the indifference curve that are in the gray area with the X bundle that is on the indifference curve. In this case, we will say that all these consumption bundles are strictly preferred to X. Why? Because all consumption bundles that are above the indifference curve are just giving more quantities than the consumption bundle X, and they are definitely located on higher indifference curves even. So this is why we are saying that this gray area, all consumption bundles in this gray area are strictly preferred to the X bundle that is located on the indifference curve. And just to make it clear, this dashed indifference curve is like an open set. So it's not included in my gray area. They are separate, they are different. So I'm just trying to compare the consumption bundle that are available in the gray area with the X bundle that is located on the indifference curve. Hopefully they are, or we can now compare between the three types of preference relation. weakly preferred, strictly preferred, and indifferent. So to put it in the notations once again, given a preference relation of at least as good as, we can define sets relative to a given point x node. I'm saying we can define sets relative to a given point x node. So we are going to put in sets, um, like in curly brackets, comparing to what is like our reference point is the point x node. So define the set of at least as good as weakly preferred x node. So this is what? This is the set of all x's, of all consumption bundles x's, such that this x is at least as good, is at least as preferred as x node. So this is the set of all bundles that are at least as good as x node. Similarly, we can define the same sets of strictly preferred, of indifferent, of different kinds of sets. As we can see, there are different types of preference relation that we can represent them with the same with sets. Okay, till now we finished two axioms: completeness axiom and transitivity axiom. And we said, just to remind you once again, and we said that they are both very important in order to, or they imply the capability, the ability of a consumer to evaluate the alternative consumption bundles and to rank them in an order, so he can say that this is the worst, this is the best, this I'm indifferent, so he can reveal his preference in a consistent manner, in a relevant manner. What is a continuity axiom? Continuity, it says that for all x, for all consumption bundles x that belong to the Rn plus space, and we suppose this from the beginning, at least as good as and at least as bad as are closed. Are closed. What do you mean by closed? Closed set contains all its limit points, boundary points. Just remember when I first put you the consumption set, I told you this is a closed set, a closed circle. This means that this circle contains all the points that are inside it, and even the points on its boundary. What does this relate to? How does this relate to the concept of continuity? This is simply to guarantee that sudden preference reversal do not occur, because the consumer imposes his preference given all available bundles in his closed consumption set. So if one bundle is preferred to another, it remains the same forever. What do you mean by this? Once again, a closed set is simply a set that contains all its inside points plus all its boundary points. So, since we already assumed that a consumer is rational, he has the completeness and transitivity assumptions. He satisfies both assumptions together. So, he can evaluate all consumption bundles, all possible alternative consumption bundles in this closed set. So he can observe all points, all consumption bundles inside the set and on boundary. So we can evaluate them all, and then he will choose the one that is most preferred to him. So once he chooses this most preferred good. Why to reverse his preference after an hour, after 2 hours? Why to do so? Why to reverse his preference? We shouldn't have so, because he already evaluated all the given bundles in this set. But if the set was open, so this means that he can only see the points that are inside the set, but he cannot see those that are on the boundary because it's an open set. So maybe if for whatever reason he saw another bundle on the boundary, he will change his preference, he will change his decision. So just to make sure that this preference will remain, we assume that the set is closed. So we have a continuity in the preference. Once the consumer chooses a consumption bundle as the most preferred to him, as at least as good as, he will have the same kind of preference all the time, always. Okay? The fourth axiom is the local non-satiation axioms. The local non-satiation axioms. Or axiom, sorry, it's not an axiom, it's just one axiom. Just to remind you, I believe you took this last year, satiation point is what's called bliss point. It's a consumption bundle that any consumer would like to reach. So whenever he's as close as possible to this point, he will always be better off until he reaches this satiation point, this consumption bundle, so to get the maximum utility ever. This is the satiation point. Okay. In our axiom, how do we call it? We call it local non-satiation. It's non-satiation. This means that we will not reach such a consumption bundle that whenever we go close to it, we are much better. We are always better off until we reach it. It's the contrary. So let's see how does it come. It says that for all x naught, the consumption bundle called x naught that belongs to an Rn plus space, and for all epsilon that is greater than 0. This epsilon is just a small positive amount, very, very tiny number. So for all x naught that belong to R plus n space, and for all epsilon greater than 0, there exists some x, some other consumption bundle x, that belongs to an open space, to an open set, epsilon x naught, such that x is strictly preferred than x naught. What do you mean by this? Just look at this graph. In this graph, we have an open ball. This is an open ball. In the middle, the notations are just different a little bit, but just try to make it with me. The point at the middle is the consumption bundle x naught. Let's assume instead of x, just x naught. So according to this axiom, we are assuming that there will always be another consumption bundle that is very close, that is neighbor to x naught, such that it will be strictly preferred than x naught. So once again, according to this axiom, the consumption bundle x naught is in an open set. We will always find another consumption bundle that is very close to x, that is neighbor to x, so that it is strictly preferred. How is it close to? What is the difference? Is just by adding this epsilon, this tiny epsilon. So it's extremely tiny difference. They might be, as if they are overlapping, but they are not overlapping. Why? Because there is an epsilon. There is a tiny the vicinity between them, the distance between them, it's very, very small. So the B epsilon x naught is a ball, an open ball of radius epsilon, centered on x naught. So our center is x naught, and whenever we just add an epsilon, we will find another consumption bundle that is strictly preferred. This axiom says that from any point x naught, you can always find a path that leads to a strictly more preferred bundle. A strictly more preferred bundle. This axiom requires that a preferred alternative nearby always exists. So it says what? That you will always find arbitrarily very close, a neighbor very near consumption bundle to x naught. But this axiom does not rule out the possibility that the preferred alternative may involve less of some or even all commodities. May involve less of some or even all commodities. Here we are not quantifying the preference. We are not saying that this is because we have more quantity than another bundle. It's all about preference. I just like this and that's it. I just like this and that's it. Sometimes for instance, you say that you have the same two bottles of Pepsi and Coca-Cola. Why do you say that I like Pepsi more than Coca-Cola? To tell you the truth, both of them have the same ingredients. They have more or less also the same quality. But your preference is just your preference. So this is the same here. I'm just saying that you will always find another close, very close, consumption bundle to X naught, so that this particular new consumption bundle is strictly preferred to X naught. Okay? Slight modification of bundle, and this is a slight modification. I told you that this epsilon is very tiny, small number, will make individual happier, will make him better off. Specifically, this axiom does not imply that giving the consumer more of everything necessarily makes that consumer better off. This assumption doesn't mean by all means that giving any consumer more of everything will make him better off. Will make him better off. This is just, as I told you, a neighbor close nearby consumption bundle to X naught will be strictly preferred to the consumer, will make him better off, will make him happier. Although it's either having more of some commodities or it doesn't have anything more of any commodity. But it only makes consumers better off, happier, more satisfied. One of the main importance of such an axiom is that it has a significant impact on the shape of the indifference curve. How does this come? The indifference curve, as you can see, we have two black bold curves, and dotted, and in between there are some dots, and we have a circle and the consumption bundle in the middle. This ball is just the ball of the radius epsilon. Let's assume so. An indifference curve is what? Can we say that both together are the same indifference curve? No. It's either one of the two black bold curves or the indifference curves, but not both of them. So this means that this axiom rules out the idea of having a thick or zone of indifference curves. This means that I cannot have such an indifference curve having two curves and in the middle I have an indifferent area. This is not reliable. This is not consistent. It does not have any reasoning. So having a thick indifference curves means that both curves together consist one indifference curve. This is not realistic by any means. And Another name of it, zone of indifference. Why I said zone of indifference? Because if I said that both curves consist one single indifference curve, this means that we don't have only indifferent bundles across the indifference curve, we have also indifferent bundles in between. And this is not the case. We always say that the higher the curve, the higher the preference and the higher the utility. So this axiom rules out such a case. So it says that an indifference curve is simply one simple smooth curve. One simple single smooth curve. There are no thick curves. A stronger assumption of local non-satiation axiom is the strict monotonicity axiom. Strict monotonicity states that for all X node and X1 consumption bundles that belongs to Rn plus space, if X node is at least as large as X1, then X node is at least as good as X1. While if X node is strictly larger than X1, then X node is strictly preferred than X1. What do we mean? Let's take the first part. If X node is at least as large as X1, then X node is at least as preferred as X1. This say that if the bundle X node contains at least as much of every good as does X1, we can say that definitely X node is weakly preferred, is at least as preferred as X1. We have X node and we have X1, two different consumption bundles. Let's assume that we have in every bundle 3 commodities. If in X node, 2 commodities have the same quantities as X1, but the third commodity has much higher quantity than X1. What will I say? I will definitely say that X node is at least as preferred as X1. So if one bundle contains at least as much of every commodity as another bundle, then the one is at least as good as the other one. The other part, if X node is strictly larger than X1, then X node is strictly preferred than X1. So if X node contains strictly more of every good, then definitely X1 is strictly preferred than X2. Sorry, X node is strictly preferred than X1. I cannot think about it. Just assume having X node and X1 and the same 3 commodities. If X node has always higher quantities in all commodities compared to X1, what can you say? I will just say that X node is definitely strictly preferred than X1. So this assumption says that the consumer will always prefer a consumption plan involving more to one involving less. And this is very rational. Any rational consumer would like to buy more rather than less if this is within his budget. If let's say with the same price, buy more or less, what will I say? What will I do? I'll just go and buy more with the same price, at the same cost. So why to buy less if I can buy more with the same price? So this assumption says that the consumer will always prefer a consumption plan involving more to one involving less. So the third point, just skip and go to the third point. Can we compare between monotonicity axiom and local non-satiation axiom? Yes, definitely. We will just say that monotonicity implies local non-satiation. Local non-satiation states from the beginning that for any consumption bundle, we will always find a very nearby, a very close, a neighbor consumption bundle that will make the consumer better off. But we said that this is an ordinal preference. I'm not talking about the quantities of the commodity that exist in the consumption bundle. Maybe I'm not having more in the other consumption bundle, but it is just give me higher preference. But in monotonicity, no, we are putting it more clear. We are just saying that consumers are always better off whenever they are consuming more. So consuming more is much better, much preferred than consuming less. So this means that monotonicity simply implies local non-satiation. So if preferences satisfy monotonicity, we will say automatically that non-satiation axiom is satisfied. But is it the case vice versa? No. Once again, monotonicity implies local non-satiation, and if so, if monotonicity satisfies preferences, so this means that preferences will automatically satisfy the local non-satiation axiom, but not vice versa. Now, we have such an indifference curve. This is just a hypothetical indifference curve. I'm not saying that if this is the correct indifference curve or not. But just before going into some explanations, just look at them. First of all, this is not a smooth indifference curve. Sometimes it takes different shapes actually. Sometimes concave, convex, it's curvy, so it has different shapes. And we have different consumption bundles, X1, X node, and X2. Can we say that the three of them are indifferent? Can I say that the consumer, once he sees these three consumption bundles, he is indifferent to them? Definitely not. Because as you can see, X1, for instance, this consumption bundle has more of both consumption commodities from both commodities compared to X node and X1 to X node and X2. So this means that any rational consumer will definitely strictly prefer X1 to X node and X2. So this is just a contradiction. So can we say that this is an indifference curve? No, this is not an indifference curve. So the importance of both axioms, of local non-satiation axiom and monotonicity axiom, is that they structure our indifference set. It says that this indifference curve is not appropriate, is not correct, as we cannot say that all points on this curve are indifferent. We cannot say that X2 and X node will give me the same level of satisfaction, because simply X node has more quantities of all commodities compared to X2, and the same for X1. So definitely this is not an appropriate indifference curve. So this is the importance of both axioms of local non-satiation and monotonicity. So this is an indifference map. This is the typical indifference map that these axioms conclude. So they are parallel to each other, and the higher the indifference curve to the right, the higher the level of satisfaction, and they strictly preferred the commodity. So in the consumer problem, both axioms, local non-satiation axiom and monotonicity axiom, guarantee that the chosen bundle will lie on the budget line. Why do we say that it will definitely lie on the budget line? Because it is simply just one line. The indifference curve will be curvy and it will be tangent to the budget line at only one point. But if we had it as before, having a concave, then convex shape, then curvy once again, so we will see that this inappropriate indifference curve will touch the budget line at different points. And this is not reasonable. Our last axiom is the convexity and strict convexity axiom. The convexity axiom states that if x1 is at least as preferred as x node, then tx1 plus 1 minus t x naught is at least as preferred as x naught for all t belongs to a closed interval from 0 to 1. I'm just reading the axiom. I will later explain. We will just make this axiom stronger, slightly stronger. So strict convexity say that if x1 is not equal to x naught and x1 is at least as preferred as x naught, what can we say about this? We can just simply say that x1 is strictly preferred x naught. Once again, x1 is not equal to x naught and x1 is at least as preferred as x naught. So we can say that x1 is strictly preferred than x naught. Then tx1 plus 1 minus tx naught is strictly preferred than x naught for all t belongs to 0, 1. Let's try to understand them. Now, sorry, let's go back to our previous slide. Let's read the axiom 5 prime convexity. If x1 is at least as preferred than x2, x naught, then tx1 plus 1 minus tx naught. What does this mean? tx1 plus 1 minus tx naught. This is simply the weighted average of x1 and x2. This is the weighted average of x1 and x2. So if we have as two extremes x1 and x2, we will find the xt in between. Why? Because this is just a weighted average of both of them. Just try to put some examples, some numbers, and you will find this. So this is just some numbers. So if I'm saying that x1 is at least as preferred as x naught, and then I took the weighted average of both commodities, of both consumption bundles, can't I say that this weighted average new consumption bundle is at least as preferred to x naught, the consumption bundle that is not as good as x1, or that is not as preferred as x naught? I definitely can say so. Why? Because on this x naught I added some of x1. This consumption bundle x naught, I added some of the more preferred consumption bundle of the at least as good as consumption bundle x1. So definitely this will give an at least as good as consumption bundle over x0. Similarly, if I'm saying that x1 is strictly preferred than x2, x1 is strictly preferred than x2. So if I take the weighted average of both consumption bundles, I can definitely say that this consumption bundle, the new weighted average consumption bundle, is strictly preferred over the bundle that is not strictly preferred, that is less preferred. So let's visualize it to make it easier for you. This is just a diagram with two commodities x1 and x2, and we have an indifference curve in which we have two extreme points, x1 and x2. Unfortunately, they all have the same or more or less the same numbers, x1, x2, but if you can just figure it out, the subscript 1 and 2 denotes consumption bundles, commodities, while the superscript identify the consumption bundles. So here we have two consumption bundles at the extreme on an indifference curve, x1 and x2. If I take their weighted average, which is t x1 plus 1 minus t x2, this will give me a weighted average consumption bundle in between of x1 and x2, which is xt. So xt is in between. xt is in between. So if I said that x1 is weakly preferred than x2, is it reasonable to say that xt, this weighted average new consumption bundle, is weakly preferred over x2? Yes, definitely it's the case. Okay, yeah. So let's read it. Suppose that we have two consumption bundles, x1 and x2, that are indifferent. Point x1, this consumption bundle represents a bundle containing a proportion of the good x2 which is relatively extreme compared to the proportion of x2 in the other bundle x2. So if you just look at the consumption bundle x2 on the indifference curve, you can see that it has much more of commodity x2 compared to commodity x1. But if we look to the consumption bundle x2, we can see that it has a higher proportion of commodity x1 and a lower amount of commodity x2. So both commodities, although they are indifferent across the indifference curve, so any consumer will just be indifferent, x1, x2, it doesn't matter, both will give me the same level of satisfaction, the same level of utility, but they have different proportions of commodities. However, any convex combination of x1 and x2, these two extreme cases, will give me a balanced new bundle. Will give me a balanced new bundle. Will give a bundle containing more balanced combination of x1 and x2. Rather than having only x2 or only x1 or much more of x2, much more of x1, it will be balanced. You will have of both commodities in a balanced way, a balanced combination. So both axioms aim to forbid the consumer from preferring such extremes in consumption. Don't go with extreme cases. Try always to be in the balanced situation. So this is what do we mean by the concept convexity. Okay. This or these two assumptions also are extremely important even in the structure of the indifference curve. Why so? Let's assume that this is an indifference curve. Let's suppose. So here we are just trying to prove with contradiction. So if you can see, just the point just above x2 is a concave shape curve. The part below x2 is a convex shape. So just analyze the concave part. Now we have two extreme consumption bundles, x1 and x2, and we have a weighted average consumption bundle, a balanced consumption bundle that have a combination of x1 and x2. xt. Can we say that xt is weakly preferred to x1? It's weakly preferred to x2? Definitely I cannot say so. Why? Because x1 and x2 both are above xt. They are on a higher level. So we can say so. So this axiom, these assumptions, rule out the concave shape of the indifference curve. They rule out the concave shape of the indifference curve. So as you can see, moving from one axiom to another, we are building our rational, relevant, consistent preference and our indifference curves structure. So this concave area is ruled out by our convexity and strict convexity axioms. So let's try just to put some concept that we heard about a lot since the first year of our university. What is the scope of an indifference curve? An indifference curve, it's a smooth curve that shows me the trade-off. Moving from one point to another along an indifference curve shows me the trade-off between the different the two commodities. So if I will increase my consumption of the x-axis commodity, I have to decrease I have to reduce my consumption of my y-axis commodity, and so on. So there is a trade-off. You cannot move along the indifference curve and increase both commodities together. So the slope of an indifference curve is simply the marginal rate of substitution of good 2 for good 1. Why did I say, okay, it's a marginal rate of substitution. This is just the substitution between two commodities. Why did I say of good 2 for good 1? Because simply the slope is delta y over delta x. And on the y-axis, we put commodity 2, and on the x-axis, we put commodity 1. So this is why we said the marginal rate of substitution of good 2 for good 1. So in order to increase my consumption of good 1, I have to sacrifice consumption of good 2. So we want to know what is the rate at which we will sacrifice commodity 2 to increase our consumption of commodity 1. So this slope measures at any point the rate at which the consumer is just willing to give up good 2 per unit of good 1 received. Thus, the consumer is indifferent after the exchange. Yes, we have been saying that along the indifference curve, we are indifferent. We have the same level of satisfaction and utility. The consumer has the same level of preference, but he can move along the indifference curve as much as he can, as much as he wants. So once there is a trade-off, and he increases his consumption from one good at the expense of another, once he rests on a point, on a consumption bundle, he will have the same level of satisfaction. He's indifferent to the previous consumption bundle consumed. If preferences are strictly monotonic means that the more the consumer always prefers to consume more. So the more the better, the more is always preferred. So if preferences are strictly monotonic, any form of convexity requires the indifference curves to be at least weakly convex shaped relative to the origin. So here we just try to mention both concepts together, strict monotonicity with convexity, so to shape the indifference curve. And we already saw the impact of both axioms on the indifference curve structure. And this point is just to confirms on this impact. So just once again to see the convex indifference curve. This is equivalent to requiring that the marginal rate of substitution not increase as we move from bundles such as x1 toward bundles such as x2. Here we are talking about bundles, not commodities, bundles, just moving along the indifference curve. This shape of the indifference curve signifies that as we move down from the consumption bundle x1 to x2, the marginal rate of substitution is not increasing. Why so? Just by sense. The consumer is no more willing to give up the commodity x2 in exchange for x1 when he has relatively little x2 and much of x1 than he has when he has relatively much x2 and little x1. So this is just to say that just put yourself on a point that is just before the consumption bundle x2 along the indifference curve. You will see yourself with a lot of quantities of x1 compared to very lower quantities of x2. So would you like more to sacrifice more of x2 to get 1 unit of x1? Or you would be reluctant to do so? You would be reluctant because you always have a lot of x1 and little bit of x2 relatively. So we will not be eager to have more units of commodity x1. So this is why the marginal rate of substitution will be less or will not be increasing when we move down the indifference curve. So convexity axiom requires the rate at which the consumer would trade x2 for x1 and remain indifferent to be either constant or decreasing as we move from up to down the indifference curve or along the indifference curve. Strict convexity axiom goes a bit further with a stronger assumption and requires the rate to be strictly diminishing. This property is sometimes called the principle of diminishing marginal rate of substitution in consumption. So what's the difference? As we said before, convexity is related to the weakly preferred preference, while strict convexity is related to the strict preference. So if we are moving along the indifference curve, just a convex, not strictly convex preference, so you will see that when we are substituting trading, let's say trading between commodities, we will have this margin of substitution. It's either constant for very close neighbor bundles along the curve, or it's decreasing. So it's either or. But with strict convexity, it's always decreasing. The margin of substitution, it's always decreasing. So this is just the difference. Just to recap for this lecture that I know that has been bulky with a lot of information, but hopefully when you read it once and twice and 3 times, you will find it easy. Just to put the main points, completeness and transitivity axioms describe a consumer who is rational and can make consistent comparisons among alternatives. So the point consistent is related to the transitivity, comparisons and ranking is related to completeness. Continuity axiom is intended to guarantee the existence of topologically nice, at least as good as, and no better than sets. So the continuity, whenever I say that at least this commodity is at least as preferred as another one, it will remain the same. It will remain the same. If this bundle is strictly preferred than any other bundle in this consumption set, it will remain the same. We will not change our choice and our preference. All other axioms like local non-satiation, monotonicity, convexity serve to characterize consumers' taste over the objects of choice. So for instance, for convexity, we have been saying that it's much better to have a balanced combination of extreme consumption bundles. Consumer is not recommended to consume extreme consumption bundles, but it's much better for him. It will be preferred, much preferred, and he will have more satisfaction if he consumes balanced combination of extreme consumption bundles. We require that tastes display some form of non-satiation, either weak or strong. Non-satiation is the weak axiom, the monotonicity is the strong axiom, and some bias in favor of balancing consumption, either weak or strong, and this is related to the convexity. Hopefully things went well with you. I hope so. I know that it will take a lot of effort from you, but I'm fully confident that you will be able to do it, inshallah, successfully. Thank you very much.